So let's take a look at this question. We have f of x, which is maximum of either 5x or 52 minus 2x square, where x is any positive real number. Then the minimum possible value of f of x is. So we have to calculate minimum of f of x. To understand this question, first of all, I'd like to uh, make graphs of this. Okay, it will be much easier if you consider how graphs can solve your very difficult problems. Instead of this, let's okay, so this is my y-axis, this is my x-axis. Okay, we have got two functions. First is 5 of x and second is 52 minus 2x square. Okay, let's draw 5 of x first. So 5x, right, it is basically y equal to 5x, right? If I know the graph of y equal to x, which is a straight line at 45 degrees to x and y axis, then I can make y equal to 5x, right? Y equal to x has a slope of 45 degrees. Inherently, y is greater, y increases 5 times more than x increases, right? Y is 5 for x equal to 1 and y is 10 for x equal to 2. So y is increasing at the rate of 5 but x is increasing at the rate of 1. So slope will be more, or the angle with x-axis will be more, hence my graph will look like something this. My graph will look like something like this, right? This is my y equal to 5x. I hope this is clear, right? So I'll just remove this, I don't need it anymore. Okay, so this is my y equal to f of x. Let me just draw it better. Okay, so this is y equal to 5x. Now let me change my color. So let's draw the second value. Now 52 minus 2x square. We know a standard graph of y equal to x square, which is an parabola which touches, right, which touches the origin. Y is equal to x square touches the origin. We just need to negate the sign. So y need y equal to minus x square because there is minus x square here. So what basically it means is, I'll just reverse the signs. Fair enough. This is my y equal to minus x square. Now at origin, when x is 0, y is 52. Fair enough. That basically means that my point of contact with y-axis at 0 is somewhere around here, which is 52. Fair enough. So I need to change my graph from this, from, just let me show you, from this to this, right? My graph is now more like this. It is like this. Fair enough. Now we have gotten, I just forgot to mention one point. This 2 does not change the nature of the graph, it just widens this. Sorry for that. It just widens this. It creates more diverged parabola. It is not affected, it does not affect the position of this. Okay. Now as you can see, if I write this in way, here is my intersection point of these two curves. Now I need to just look at this quadrant, this quadrant number 1. Why? Because I have given x is any positive real number, right? So I'll just look into the first quadrant. Now when I say that my f of x is maximum of first function and second function, right? So before this intersection point, my maximum of f of x, which is 52 minus 2x square, right? And after f of x, after this intersection point, my maximum is 5 of x, right? But as you can see from the graph, the minimum value is at the intersection point, right? So I have to calculate the minimum possible value of this f of x, which is at the intersection of these two functions. So what I just need to do is, intersection is basically at a point where both these will have same value, which is 5x equal to 52 minus 2x square. I just take everything to the left hand side, 2x square minus plus 5x minus 52 equal to 0, and I'll get some solution of this, which is the answer. I have to figure out what is the solution for this equation so that I can get minimum of f of x. I hope this is a fair value. I At this point, I'll just remove the graph and just solve this quadratic equation. So let's look at the quadratic equation that we have. 2x square plus 5x minus 52 is equals to 0. So 52 into 2 is the factorization that we need to do, a into c. 13 into 8, I think 13 minus 8 is 5, so this is okay. So 2x square minus 8x plus 13x minus 52 equal to 0. To factorize this further, 2x we can take common, so this becomes x minus 4 plus 13 we take common, x minus 4. Hence we get answers 2x plus 13 and x minus 4 equal to 0. Now these are the two solutions, but x is equals to minus 13 by 2 is not a solution, because we are just considering the first point, the first intersection, right, in the first quadrant. So x has to be positive. Hence the value we will consider is x equal to 4. So if we put that into the function that we have, at that point f of x will have the minimum value. So f of x is maximum of 4 into 5, which is 5x, comma 52 minus 2 into x square, which is 16. So it's 20, and 52 minus 32, which is 20. So maximum of these two, because they are equal, the maximum of these two, 20 comma 20, is 20, and which is the minimum value of f of x. I hope this graphical understanding is there, and I hope the question is understood by you all. I'm really sorry this took a long video, because this parameter I wanted to explain, because this is important in a lot of different questions where maximum or minimum of something is there. A intuitive understanding of where these graphs will intersect, and when they intersect the value will be 0. That is very important. I'll see you in the next one.